Welcome to Embedded Laboratory. In this video, I will show you how to connect DST11 temperature and humidity sensor, RTC DS1307 and SD card with Arduino Uno. We will get the temperature and humidity data from DST11 sensor and store it in the SD card with timestamp. And the file name will be equals to the current date. So let's get started. This is the location of the project where I will save my source files and the Proteus design files. I will use PlatformIO framework for this project, but the same source code will work on the Arduino framework also. First step is to create a new project and then select the Arduino Uno as the development board. In the framework selection, I will select Arduino and then I will save the project in my preferred location. As you can see, the PlatformIO extension has automatically generated all the required files. This is the main file in which I have to write our software. This file is equivalent to INO file in Arduino. As we have to interface DST11 sensor with the Arduino Uno, as the next step, I will add the DST sensor library to this project. This can be done by clicking on the libraries and then search for the DST11 sensor in the search box. As you can see, the list shows a lot of DST sensor libraries. But for this project, I will use DST sensor library from the Adafruit. Click on this library and then click on Add to Project button. Now include the DST sensor header files and build the project. If it is building fine, it confirms that everything is fine. Now before proceeding further, the next step, I will check if the LED blinking is working fine or not. I will use the onboard LED on Arduino, which is connected to pin 13 of the Arduino board, and will make it blink at the rate of 1 second. So our code is building fine. Let's prepare the Proteus simulation file. Load the hex file in the Arduino Uno microcontroller. As we can see, LED toggling is really working well. Let's test the serial port also. We have to just add a print statement. So as you can see, our serial prints are also working well. This is really important for debugging purpose in case there is some issue. Let's work on integrating the DST11 sensor. As we have already added the library, this can be seen in the platform.ini file. The library is already present here. Now let's work on adding the code related to DST11 sensor. We will use the same approach which we have used for LED blinking. that is writing the software in a non-blocking way. The pin 2 is selected for connecting the DST11 sensor output. DST11 coding part is completed. Let's build and test in the Proteus simulation environment. Note, we have to pull up the data line of the DST11 sensor and also make sure that the resistance type is of type digital. It looks like that it is working fine. Changing the temperature and humidity values in the simulation is also possible, and we can see the value on the serial terminal is also same. Great. Now the next step is to include a real-time clock. In our case, we will use DS1307. I2C bus, SDA and SCL lines are by default an open collector or open drain in nature. Hence, we need to connect an external pull-up resistors on both of these lines. While working in simulation, make sure that the resistor is of type digital. Now let's start coding. As a next step, we have to include the RTC library, and here we have to follow the same steps. First, click on Libraries and then in the search box type DS1307. So we will use the RTC lib library provided by Adafruit. After adding the library, include the header file and try to build the project. And it fails. The error message is clear that it needs SPI library. I tried by adding the Adafruit bus library, but that doesn't fix this problem. Anyways, I will show you how I fix this problem later. Meanwhile, we can continue writing the source code for RTC DS1307. I have declared a RTC object with some other variables to store time and date information. As a next step, in the setup function, we will initialize the RTC, and if initialized properly, we will display a RTC connected message, else an error message is displayed. Project is still giving the error due to the same reason spi.h header file is missing, and to solve this issue I will include this library in the platform.ini file, and this will resolve the issue. Let's start updating the loop function to get the time and date information from the RTC, and then we will update a buffer with time information and temperature and humidity data, and then this whole data will be transmitted to serial port. This project is compiling fine. Let's test this in the simulation environment. Okay, there is some problem. I don't know if you have noticed this or not, and the problem is RTC is not connected with Arduino. Arduino AD4 and AD5 pins are SCL and STL line. Let's update the simulation accordingly and check if this is working or not. As we can see, this is working fine. So now one last step is remaining, which is logging this data into the SD card. In Proteus, I will import the SD card breakout. Here we don't need to change anything in the connections, unlike for RTC. We have to just make sure that the chip select pin is pin 4, and this must be configured accordingly. Now let's add SD card library provided by Arduino. Add this to the project. I will also change the buffer name to SD buffer to indicate that this is associated with the SD card. In SD card, we have to store data with a file name, and in our case, file name will be the current date. In the setup function, we will check if the SD card is initialized or not. If initialized, a positive message is printed. In loop function, file name is made using the current date information. And then we will open this file in write mode and save the content of the SD buffer, which contains the current time, temperature and humidity data, into the SD card. Let's build the code and run the simulation. Card is initialized. It looks like everything is working fine. I will pause the simulation to see the content of the memory card. As can be seen that the file is created with the current date name. This is okay. I will export this file to see its content. Strangely, there is nothing in this file. Now I need to debug for its root cause. I found a mistake. I forget to close the file after opening it in the writing mode, and this has corrupted the file. Let's fix this and test again. Now as you can see, everything looks fine. We can see the data is written into the file properly. That's all from this video. If you have any question, feel free to contact us. If you like this video, press the like button, subscribe to this channel and share this video with your friend. Thank you.